Hi there. In this session, let's start discussing how to interface sensors with Raspberry Pi. And before doing that, we must know what is exactly a sensor. So let's start discussion with what is exactly a sensor. Sensor is basically a physical component which can sense changes into some kind of physical quantity or some kind of physical parameter. Like there is a sensor for temperature, then for pressure, humidity. There is also sensors for LPG leakage as well as detection of alcohol. Then you know about the sensors present inside your phone, which includes a compass as well as a proximity sensor which turns off the display when the call is on, and so on. There are hundreds of different types of sensors which are available, and all of them can be used in electronic projects. Depending upon what type of output they produce, these sensors are broadly classified as analog and digital sensor. For example, let's see there is a small sensor available which is called as LDR. Now it's simply a resistor which displays the changes or which shows the changes in resistance whenever the light falling onto it changes. So let's see in detail about the sensors. So as said, depending upon the type, broadly sensors are classified as analog or digital sensor. Analog sensor means some sensors which are fabricated to give a calibrated analog output. Now what I mean to say by calibrated analog output means at the time of manufacturing the sensor itself, the outputs of the sensor are calibrated to the physical parameter that it has been sensing. To give you an example, LM35 is a very recent temperature sensor which gives analog output. And the analog output it gives is 10 millivolt per degree Celsius of temperature. So for example, if right now the room temperature is 25 degrees Celsius, the LM35 will give 25 multiplied by 10. It means 250 millivolts as output. So this is a kind of sensor which we can call as an analog sensor. And then there are some sensors which are fabricated to give a digital output as well. The digital sensors, or the ones which give digital output, give data onto some kind of digital communication mechanism or something that we technically call as protocols. There are a number of different types of protocols like one-wire protocol, I2C protocol, SPI protocol for communicating digital data with something like microprocessor or microcontroller. With Raspberry Pi, we have to understand one fact that you cannot directly interface an analog sensor like LM35 to it directly, and Raspberry Pi natively only supports digital sensor because on Raspberry Pi board itself there is no analog to digital converter. But if you have to connect an analog sensor like LM35 to Raspberry Pi, what you need to do is you need to use an external A to D converter. Now in this session what we are going to do is we are going to see some of the sensors which are analog as well as digital. So let's see. The very first one that we can discuss is an LDR or light dependent resistor. Now LDR is by its nature, you cannot call it as an analog sensor because it cannot directly give you an output. It's just a resistor and we have to create a conditioning circuit around it so that it can give an analog or digital feedback to us. The working of LDR is very simple. It's basically a resistance. This is the circuit symbol of LDR, and the resistance of LDR changes with respect to the fallen light onto it. If there is very low or no light falling onto the LDR, it means there is a dark condition. In that case, the resistance of LDR is very high. And when there is sufficient light or when there is enough light onto the LDR, in that case, the resistance offered by it is low. If the light is much brighter falling onto it, the resistance is lowest. And if the darkness or if the light is very dark, there is no light falling onto the LDR, in that case, the resistance it offers is highest. Now let's see how we can interface the LDR with Raspberry Pi even without having an analog to digital converter. So let's see the simple hands-on in next exercise. Now let's see how we can interface the LDR with Raspberry Pi. As said, more light means less resistance offered by it and less light means more resistance offered by LDR. And therefore, whatever signal conditioning is to be done onto the LDR, we have to do it in our interfacing circuit. Now let's see the interfacing circuit for LDR. Now as you can see here, we have to create an interfacing circuit like this, where we have LDR interfaced with a capacitor like this. Now the working of the circuit would be very simple. One point of the LDR goes to 3.3 volt. Second point of LDR goes to a junction, whose one point goes to the GPIO pin of Raspberry Pi, and the second point goes to the capacitor's positive pin. The negative pin of the capacitor goes to ground. This is supposed to be an electrolytic capacitor, and therefore it has its own positive and negative terminals. Now let's see how it will work. Now as you can see, one point of the LDR is going directly to 3.3 volt over here, and this pin is going to Raspberry Pi GPIO. So the algorithm would be something like this. Initially, what we will do is we will make the Raspberry Pi pin act as input. So very first thing is Raspberry Pi pin will act as input pin. And what we are going to do is we are going to write down an algorithm where we can sense the voltage onto this pin when it goes from 0 to 3.3 volt. As soon as it becomes 3.3 volt, we will read it as logic 1, and when it is 0 volt, we will read it as logic 0. This is how the interfacing is done. So let's first understand the logic. Now to be precise, let's see how the exact algorithm should be. Now let me clear it, whatever was previously done. Now what we will do first is see. One point of the capacitor is going to ground and the second point is going to Raspberry Pi. So the very first step in our program should be this particular GPIO pin will be made output. Okay, we are going to read it as input, but first let's do it output. And in the second step, what we do is we make the particular pin as false, or write a false value onto the output, which will write a 0 volt onto the output. Now what happens because of this 0 value, this pin of Raspberry Pi, this pin will become 0 volt. This pin is already ground, means 0 volt. So in this condition, what will happen? The capacitor will be completely discharged. So there is no charge on capacitor at all. Now what we will do is we will be making the pin work as input. So now the GPIO will work as input pin. But we won't enable any pull up or pull down. So it becomes, or it stays, a tri-state pin. Now what happens because of tri-state nature of the pin? Let's see. Now what will happen is, depending upon the light falling onto the LDR, the capacitor will receive some amount of current, and based upon the current received through this resistor, the capacitor will start charging. Right now the capacitor is completely discharged, so the potential at this point which can be read is 0 volt. As the capacitor starts building charge, its voltage will rise slowly, something like this. So it's 0 volt, and based upon the LDR, it will rise something like this. And after some point, it will reach to a value, let's say 3.3 volt, if this is the 3.3 volt threshold bar that we want. And it's sure to take some amount of time in reaching to that point. Now if there is a dark light, completely dark room, in that case the capacitor will take full time to charge, because the resistance of LDR would be highest. And because of the highest resistance, what will happen is the current flowing through the capacitor would be very slow or very low, and therefore it will take a lot of time to charge completely. Whereas if it is a well lit room, or if you are holding a light source onto the LDR, then it will charge rapidly, because in that case what will happen is the resistance offered by it will be too small, and therefore the current flowing would be large enough to charge the capacitor faster. Now what we will do in our program is we will try to measure the time. We will try to measure time needed for this pin to become 1 or to become logic 1. Now let's see. This is the interfacing diagram of LDR and capacitor with Raspberry Pi. So this is exactly like this. You can use a 1 microfarad capacitor or a 10 microfarad capacitor, but don't use more than 10 microfarad capacitor. 1 to 10, any value would be okay. This is the interfacing diagram. One point of the LDR is going to 3.3 volt over here. Second point of LDR is going to capacitor, and the same point is also going to pin number 21, GPIO 21 that we have been using, and the second pin of capacitor is going to ground, exactly as shown over here. Now let's try to understand the program for it. Now this is the program and this is the algorithm, if you can see. So what we said first was we'll make the GPIO pin work as output pin. So here we are setting it as BCM, we are specifying pin number, and in while true, what is the first thing that we did? We first made the particular pin here to work as output pin. Okay. Next what we did, we write the pin to 0 volt. That will ensure that the capacitor gets completely discharged. We also wait here for 1 second so that the capacitor is discharged completely. And then what we do is we make the particular pin work as input pin. Tri-stated input pin, you can see. And then the line is while GPIO.input pin is equal to low, reading is equal to reading plus 1. It means basically this program will continue as long as the pin is low. And as long as the pin is low, what will happen? A variable called reading will be incremented by 1 continuously. Now when that pin will become 1, or whenever that pin becomes 1, this particular while loop will be broken. Till then it will keep making the readings increment by 1. And when the pin becomes 1 or when the pin will become 1, whenever the LDR is fully charged. So after this point, at this point, when the LDR, the capacitor charge becomes 3.3 volt at this point, this particular while loop will be broken. And then what we do is we print the reading onto the terminal, and then we again wait for 1 second before repeating the entire loop. So as you see, first of all, make the pin output. Then what we do is we make the particular pin 0 volt. Then we wait for discharge. Then we make it input. And then we again wait. Now what we wait for? To become true or 1. And while we wait it, what we do is we increment a variable. Now when you print the value of this variable, it will directly indicate, or it will be directly proportional to the amount of light falling onto the LDR. If the amount of light falling onto the LDR is very low, or if it is very dark, then the reading will be high, and when the amount of light is sufficient enough, the reading would be low. In this sense, I can say that the print value would be inversely proportional to light falling. So if the light is high, the reading we are supposed to get is low, and when the light is low, the reading we are supposed to get is high. Now enough of theory, let's try to see it practically when we interface the capacitor and LDR with Raspberry Pi. Let's see that in next video, and let's see the output. Now as you can see, I have an LDR over here, and this is how it looks. It's basically a 2-pin component, and it can come in smaller size also. This one here is a medium size LDR that I have. Now let's try to check it. So this is a multimeter I have over here. Let's put the multimeter onto the resistance or this ohm meter mode and let's check the LDR. Now the multimeter is in the resistance measurement mode, and now what I'll do is I will connect these 2 points of LDR to the multimeter. Now as you can see, it's calculating the resistance and it's about 1.4K. And if I give darkness onto the LDR, you can see it's 6K, 7K, 8K. If I make it completely dark, it's something around 48K, you can see. That's the resistance the LDR is offering. Now if I keep it as it is, then it is 1.3 kilo ohm, and what I have here is a torch light in the battery bank. So let me just keep it like this. So if I take the LDR in front of full light, I'll just hold it like this over here. Now you can see the resistance is so reduced that it's about 100 ohm and something, 70 ohm. This is natural room light. On natural room light, you can see the resistance coming out to be something like 1.3K, and when it is mid dark, it's something like 50 kilo ohm or so. So that's how you can check the LDR. Now let's proceed further. Now I have the Raspberry Pi working over here, and I have a breadboard. This is a 1 microfarad capacitor that I have. Now the negative of capacitor is easily identified by this kind of white patch onto it, which indicates a negative symbol. Now what we need to do is we need to connect the LDR just as shown onto the schematic. So one point of LDR will go into the breadboard's one pin, other point will find another suitable hole, and then a capacitor from that second point to another point onto the breadboard like this. There isn't much to the connections. Now let's connect the Raspberry Pi to it. So this is where I'll connect 3.3 volt anywhere here, and this is the ground pin. And then what we need is the data pin. Data pin is the middle one, which is here, as you can see. The combination of LDR and capacitor is the data pin. Now my data pin will go to pin number GPIO21. Then this one will go to 3.3 volt. And this one will go to ground. Now it's good. Now my connections are done. Now it's time to write down program onto the Raspberry Pi, and let's see the output. Now let's connect to the Raspberry Pi through VNC viewer, and let's try to write down the same program over there. Let me do the remember password check mark. This is my Raspberry Pi. Now what I want is I want to open the Python editor here. So let's open terminal and let's type sudo thony. So sudo gives us permissions to deal with the GPIOs. That's why sudo. Now let's try to create a new file and let's save it. So I'll call it LDR test. In the Pi folder, I'll save it as LDR test. Now all we have to do is we have to copy this code over here. That's the code. That's about it. Now let's try to run this program. The output should be shown in this window over here. So the print reading should be in parenthesis. That's it. No other change is needed. Now you can see a number has been printed called 1303. Okay, 1303 has been continuously printed. Now if I take my hand near to LDR and if I bring some darkness onto it, you can see the number is increasing. If I reduce it and keep it in normal room light, it is again close to 1287, 1299. If I again take the hand above it, you can see the reading increasing once again. Now if I take the torch light and put onto it, then you can see the reading will drastically reduce. 200, 250, 300 and so on. 131, 185. So this can be a very simple experiment, but it can also act as a clear indicator of how much is the light present in your room. So this is normal light, you can say. This is darkness. You can say something greater than 4000 is darkness. Something greater than 10,000, it's complete darkness. So now you can see, I have put my finger onto the LDR and the reading is more than 15,000, 18,000 or something. And so on. Now using this simple program, you can create any light related mini project. I will repeat that this is not a perfect indication of lumens of light that is present in the room, but it's a definitive indicator whether the light is sufficient, it is dark, or it is brightly lit, or it is super brightly lit. Now you can perform this experiment and see the output for yourself, and you can also perform some tasks based on it. Thank you for watching this video.